Alright, what's up gamers? Here's a video that is quite out of the ordinary. I mean, at this point, any video is out of the ordinary because I don't fucking post. But, anyway. Today I want to discuss an interesting problem that I have written myself, actually. And it should prove very helpful to those who are looking to participate in AMC, or American Math Contest, and AIME, or American Invitational Math Contest, or math exams. So I'm sure those who have a little experience have probably seen many problems where they give you some function and give you some really wacky looking formula. And the wacky looking formula questions, you should do them. You should try them because they usually turn out very easy. Well, anyway, let's get on with the problem. So, in this problem, we let a1 equal 3 and define an to be equal to an minus 1 minus 2n plus 8 for integers n greater than 1. And we're asked to evaluate this expression. Some of the answer choices are below. So clearly it's probably not going to be E, because 911 does not equal 0, so we can cross E off. So really we're looking at A, B, C, or D. Anyway, let's get on with it. So, A equals 1. A1 equals 3. So let's just evaluate a few values. This is usually a good idea when approaching recursive problems. Usually there's some pattern you'll see. Let's see. A1, in this case, equals 3. So A2 would be equal to A1 minus 2 times 2 plus 8, which in this case would come out to be but in this case, we get that equals 7. You see, so we have A1 equals 3, A2 equals 3 minus 4 plus 8 equals 7. And let's do another one, A3. A3 would be equal to A2 minus 2 times 3 plus 8. In this case, we have A2 equals 7, so 7 minus 6 plus 8. All this gives us 9. Alright, what do we see? We have 3, 7, and 9. Not quite sure what to do with these, so we'll hold off on that for now. Let's move on to this lovely expression that we have. Let's just write it out a bit, actually. So big pi notation is actually not very common, but I'm sure you guys all know what it means. It's the same thing as the sigma, except you just multiply. Anyway, let's get rid of the big pi and let's just write out all the sigmas. So what this is really asking us is to evaluate the sum of, let's start with n equals 1, so it goes from 1, I equals 1, 10, in this case, if n is 1, we just have 1 minus I, times a I. And then we continue on, because that's how pi notation works. Alright, so that does not look very pretty, but I assure you, when you see problems like this on the AMC or AIME, they usually turn out really nice. So, actually, this looks very complicated, but it really isn't, especially this one here. If we simplify this, we find, okay, it just goes from 1 to 1, so really we can just plug in 1 for I, and we're done. So 10 to the 1 minus 1 would be 10 to the 0, so the 10 just dies, and we're left with AI, and I is 1, so just A1. Moving on, we have pretty much the same thing. We can probably just evaluate this, and it'll be good enough. So if I equals 1 in the first case, we have then 10 to the 2 minus I, which is 1 power, to the multiplied by A1. And then when I equals 2, we're left with 10 to the 2 minus 2, so the 10 dies again, and we have then a 2, except remember this is a sum, so we have to add the 2. Okay, we're looking good. If we continue on like this, we've already solved for A1, A2, and A3, so really, we're set. So we just have to crunch out the numbers. See, it looked like a really tough question, but really, if you just try to attempt it, it should turn out quite nice, usually. All right, so last one. I'll just crunch this out. I'm sure you guys can figure it out yourself. We'll have A1 plus 10 times A2 plus A3. Very nice. So now all that's left is to evaluate it. And really there was no real trickery in this problem. Okay. So A1 we've solved equals 3, right? If A1 equals 3, A2 equals 7, and A3 equals 9. So we have 3, and then multiplied by 10 times A1, which would be 30, plus A2 equals 7, so times 37. And then this last one will be 300 plus 70 plus 9, so that'd be 379. All right, let's crunch out the numbers real quick. So 3 times 37 is 111. Let's leave the 379 as it is. We'll just do some long multiplication. We have 379 times 111 be 379, 379, 379. Let's just add it up. 9, 6, carry the 1, 0, 2, and 4. All right, so it looks like our correct answer is B. And yeah, that's pretty much it. I hope this was helpful to you guys who are looking to looking to participate in the AMCs and the AIMEs. I wish you guys luck, especially with the up-and-coming AOIME, which is just going to be the online version of AIME. This is going to be coming up. Anyway, I hope you found this problem helpful and interesting. Yeah, thank you for watching.